we are going to see convolution theorem proof. Convolution theorem proof. If this is the convolution theorem, f of s into g of x, product of two functions of s equal to 0 to t f of t minus u g of u du. This is we are going to prove. This is called convolution theorem. We know L of f of t equal to 0 to infinity e power minus st f of t dt. Whatever comes in L f of t, the same comes in the integral. Therefore, 0 to infinity e power minus st dt are permanent. We are integrating with respect to t only. S is other than t. Therefore, result will be function of s. This is the basic Laplace transform we know already. See, we are taking here f of s is product of the function. This is also a function. These two also product of the two functions f of s and g of s. Let us take f of s as 0 to infinity e power minus u. Here instead of t we are giving u here. F of u du. Again for g of s. G of s equal to 0 to infinity e power minus sv g of v dv. This is here variable is t, here variable is v here. Result is g of s, a function of functions of s. We are multiplying both these f of s and g of s. F of s into g of s equal to f of s is 0 to infinity e power minus su f of u du. 0 to infinity e power minus sv g of v dv. Both are multiplied. Again, taking the integrals commonly outside, f of e su e power minus sv f of u gv this du dv. Equal to 0 to infinity e power minus su minus sv f of u g of v du dv equal to 0 to infinity e power minus s of u plus v. S is taken as common, it also common. F of u g of v du dv. Again taking, put u plus v equal to t. Consider v as a constant. Then du equal to dv dt. Since v is a constant, differential of du, differential of t. See, one limit is belongs to u, another limit is belongs to v. U limit is, lower limit is 0. If u equal to 0, v equal to t. If u equal to infinity, you put infinity, infinity into infinity equal to t. Again, u equal to t minus v. We are all applying in this integral. Equal to 0 to infinity, which is belongs to v only, this integral. This is change as a t. See, our lower limit is 0 means v equal to t equal to v. T equal to v. If you give upper limit, u infinity, t also infinity. This belongs to limit is belongs to t only. We have substituted u plus v equals to t. St, v is a constant. E power minus s, u plus v is t. And u is t minus v. gv. du equal to dt. dt, dv. Completely changed by applying u plus v as t. We have to change out of integration by writing a diagram. Let us take the limits first. 0 to infinity, v to infinity. If v is there in the limit, that integral belongs to t only, opposite variable. Therefore, if v is there, we are putting equal to t. It belongs to t. Another limits are v equal to 0, v equal to infinity. See, again I am telling here, v to infinity, 0 to infinity. If the limit, one limit is, if limits are in v, that integral belongs to t only. Therefore, we are equating t. Another limits are v. This only we have written here. Again I told you. See, all 1, 2, 3, 4, all these take as a curves. V equal to t, or t equal to v, t equal to infinity, v equal to 0, v equal to infinity. See, v equal to t, t equal to infinity, v equal to 0, v equal to infinity. And drawing a diagram by applying these 4 equations. See, this axis is t axis, let this axis v axis. You can, this as t or this as v. Anyway, you can take the axis to change the order of integration. By change the order of integration, changing the order of integration, by changing the order of integration, we are changing the order. See, t equal to v. This is the equation of this line. T equal to v. T is infinity. This is the axis. T equal to infinity. V equal to 0. V equal to 0 is here. The axis T is called v equal to 0. At all places, v is not goes up. Therefore, v equal to 0. Here, v equal to infinity. Here, v up to goes up. As t tends to infinity, we also goes up to infinity. Let us carefully should give the we should carefully give the shades of the diagram. Here, v equal to 0, t equal to infinity. These two variables come in same line. Therefore, V is infinity. V is infinity. This cuts, the line is cuts here. Therefore, we should give the shade here only. It goes up to infinity. Again, I am telling, this is t axis, v axis. T equal to v, we know x equal to y. We know the axis in lower standard, in 10th standard, x equal to y. This is 45 degree. 45 degree. Similarly, t equal to v, this is 45 degree. Again, v equal to 0. In t axis, always v equal to 0. V equal to 0. T goes up to infinity. V also goes up to infinity. 1, 2, 3, 4. 4 equations we have drawn in the diagram. First equation is t equal to v. Second is t equal to infinity. That is v equal to 0. Fourth is v equal to infinity. This is the two curves are the t axis. Therefore, this is the required shadow region. V equal to infinity cuts here at the origin. We are changing the order of integration. See, change the order of integration. One variable moves in the axis, another variable is bottom to top. This is important in multiple integrals, in changing order of integration. One limit is goes in the axis. T turns to infinity. T goes up to infinity. Equal to, this is equal to, we are giving this equal to 0 to infinity. T goes up to infinity. But V is the shadow region bottom to top. See, bottom V equal to 0. Top V equal to T. This is the way of change order of integration. Again, I am telling you, these 4 curves we have drawn in the diagram. This T axis, V axis. T equal to V, we know x equal to y in the basic 10th standard, x equal to y. This is T equal to V, this line. This is 45 degree, this is also 45 degree. Again, V equal to 0. The in T axis is called V equal to 0. Another variable V equal to 0. Wherever it goes up to goes in the upper side. Therefore, V equal to 0. T is infinity. T goes up to infinity. This is the axis. Here, similarly, V also infinity goes up to infinity. Here is two curves in this diagram. T is infinity, V equal to 0. 2 curves here. Therefore, this region is the required shadow region. Again, we have changed the order. In the changing the order of integration, one variable moves in the axis. This is the axis. In this shared region, T is 0 to infinity. T is 0 to infinity. Another variable is bottom to top. This is the easy way of writing changing the order of integration. See, lower limit is V equal to 0. Lower curve is V equal to 0. Upper curve is V equal to T. Bottom to top. If you take in the V axis, left to right, we will use later in multiple integrals. See, you can see the same in this diagram also. If you take V axis, V to infinity, V is 0 to infinity. T is, another variable is T, is left to right. T is V. T is V. Right T is infinity, goes up to infinity. Goes up to infinity. We can tell the same, from the same diagram, we can say the same limit. If 0 to infinity, V tends to infinity, V tends to infinity. And the T equal to V, T equal to infinity. T equal to V, T equal to infinity, T equal to infinity. It goes up to infinity, goes up to infinity, goes up to infinity. The T is a curve. This is a curve. Left to right. Left is T equal to V. T is infinity. This is infinity. Similarly, we are seeing on the T axis. T axis is one variable moves in the axis. Another variable is bottom to top. C 0 t goes up to infinity, 0 to infinity. Another variable v is 0 to v equal to t, v equal to 0 to t. Same we are writing v equal to 0 to t, e power minus st f of t minus v g of v dv dt. We have changed the order of integration. We have changed the order of integration. Again I am telling, one limit is in changing the order of integration. One limit moves with the axis 0 to infinity. Another limit bottom to top. Another limit is v equal to 0, v equal to t, v equal to 0, v equal to t. We have changed this order of integration. Again 0 to infinity in bracket 0 to t f of t minus v g of v dv of dt. We have taken v as separately. See, left side is what? F of s into g of s. 0 to infinity in bracket 0 to t f of t minus v g of v dv dt. In Laplace transform, L of f of t, here writing in the blue, f of t equal to 0 to infinity e power minus st f of t dt. I have not written e power minus st, the top. E power minus st 0 to t f of t minus v g dv d of dt. I have not written e power minus st. See, in this Laplace transform, e power minus st f of t dt 0 to infinity e power minus st, this complete is taken as f of t dt. This is equal to Laplace transform of 0 to t e power f of t minus v g of v dv. Again, see here, this is completely called function of a function. See, L in L, only f of t is there. Similarly, 0 to infinity, e power minus e minus t. This complete taken as f of t. F of t is inside this. dt, f of t is inside this. Again telling, e power minus t, f of t dt. Therefore, L of f of t, L of this is completed. Here f of t is act like this here. L comes to this side. L inverse of f of s into g of s equal to 0 to t f of t minus v g of v dv. This is the convolution proof. Again, we can change the variable v as u. See, L inverse of f of s into g of s equal to 0 to t f of t minus u g of u du. We have dummy changing. Instead of v, we have taken u. This is the step we have used in the solving sums. You can give any variable instead of u, any variable, L inverse of f of s into g of s equal to 0 to t f of t minus z g z d z. You can give any variable. These are all dummy variables. These are all called dummy variables. This is the only line we are using in this convolution theorem. Hence a proof.